Here I want to go through 6F with scientific notation. So numbers written in scientific notation are expressed in the form a times 10 to the m, where a is less than or equal to 1 or less than 10. Or a is less than minus 10 or less than and equal to minus 1. So large numbers will use positive powers of 10. For example, when writing 38 million years, this is the same as saying 38 with 6 zeros. Or we can write it as 3.8 times 10 to the 7 years, which will equal the same thing. For small numbers, we will use negative powers of 10. For example, 417 nanoseconds will be the same as 0.000000417 seconds. Instead of saying this number with 6 zeros, we can just say 4.17 times 10 to the negative 7 seconds. So why scientific notation is important is because when we have numbers which are either too big or too small, it makes calculating and writing them out much easier to work with. As you guys can imagine, if we just forget 1 zero or if we add 2 or 3 zeros, the number may be overcalculated or undercalculated. So to write numbers using scientific notation, place the decimal point after the first non-zero digit. So place the decimal point after the first non-zero digit, then multiply the power by 10. So let's read through some examples here. Examples of units which very large or small numbers may be used. So the first one we have is 2,178 kilometers. In meters, this would be 2,178,000 meters, or 2.178 times 10 to the 6 meters. 4,517 centuries, this would be the equivalent of 451,700 years, or 4.517 times 10 to the 5 years. 12 million years is the same as 12,000,000 years, or 1.2 times 10 to the 7 years. So a good way to look at it is if we take this example here, so 1.2 times 10 to the 7 years. If I write out 1.2, we know we need to multiply this by 10 to the 7. So what I like to do is get my decimal point and move across to the right 7 times. So it's 1, 2, 3, 4, 5, 6, 7. Now we want to fill out the gaps with zeros, and that's where our new decimal point would go. So as you can see, the comma goes here, 12, 1, 2, 3, comma again, and we get 12 million years. Okay, so that's a good trick that you guys can use. On the other hand, if we're looking at very small units, so 27 microns, so a millionth of a meter, this would be the same as saying 0.000027 meters, or we can just say 2.7 times 10 to the negative 5 meters. So if we apply our trick, we have 2.7 times 10 to the negative 5. So if it's raised to the power of negative 5, you want to go to the left 5 times. So 1, 2, 3, 4, 5. So your new decimal point goes here, and you want to fill in the gaps with zeros. So now we get 0.00027 meters. Okay, let's try some examples ourselves. So write the following numbers using scientific notation. So the first one with A, we have 720000. So what I want to do with this one is we want to put the decimal point straight after the 7. So it goes 7.2. And ask yourselves, how many times do we go across? So if I grab a pen here, we go across 1, 2, 3, 4, 5 times. So that's 7.2 times 10 to the 5. With the second example, we have B, which says 0.00003. So ask yourselves, how many times do we need to go across in this side? 1, 2, 3, 4, 5, 6 times. So this becomes 3 times 10 to the negative 6. Okay, let's try the next one. Express each of the following in decimal form. So for A, we have 6.17 times 10 to the power of 3. So we need to move our decimal point across 3 times. 1, 2, 3. So there should be a 0 there. So our answer should be 6,170. In example B, we have 4.02 times 10 to the negative 6. So once again, the easiest way is to write out our decimal, so 10 to the negative 6, and move it across 6 times to the left. 1, 2, 3, 4, 5, 6. Fill in your gaps. That is where the new 0 goes. So the number that we have is 0.3450. 1, 2, 3, 4, 5, 402. Okay, so that's it from me. Hopefully you learned something, and I'll see you on the next one.